Is there anything else you need from me other than introducing you now, or are you all set, good to go?
I think I'm all set. Yeah, thank you.
Perfect. So for those of you on the call, if you have any questions, type them into the chat or in the Q&A panel. We'll save them up for the end at the session. And since we're now right at past, I will introduce Etienne, doing a session on more performance. It's on the tip of your fingers. So Etienne, stage is all yours. Take it away.
Catherine, thank you so much. So it's a great pleasure to be here on this event, GroupBy. And first of all, there are some things that need to be said. The code of conduct that exists that mainly regards being nice to each other, not offending anybody. We are here to have a very nice time and to talk a little bit about something that we are all passionate about, which is SQL Server, right? So that's what we're going to do. Who am I? Well, my name is Etienne Lopes. I'm working at Aramix at the moment, which is a Portuguese company where I'm in. And it's specialized in data services, and it has also a unit totally focused on performance, which is what we're going to speak here today. I also have a little blog. I'm not going to show you the blog. I'm just going to show you a landscape that I think it's a great view. I've had the privilege of being here in person, and I can assure you it's really great. So after pandemic and all it brought, so it's very delightful to be able to go back to places like this. And well, I'm a SQL Server enthusiast. Basically, I've been working with SQL Server since 1997 until today, and it's always been a great passion for me. And I also am a regular speaker in SQL Server events since 2012, and I hope you guys will find this event interesting as well. Regarding our sponsors, a big thank you to them, since this kind of events would never be possible to make without their support. So thank you so much for supporting us, for helping us passing this kind of knowledge and sharing the knowledge with others and letting the others sharing their knowledge with us. So thank you so much for your support. And well, this is the title of my presentation today. So make yourself comfortable, and the movie is about to begin. Okay, you can still pick the popcorns if you like. And I'm also dropping this tip. Okay, don't tell anyone that I said this. Okay. And well, if we're all set, then here we go. So this is going to be a demo-based presentation. Okay, it's basically everything is going to be about demonstrations, and these demonstrations are based in real-life scenarios. Okay, so there are things that happened to me along the way. Some of them are very frequent. We find them very often. For instance, one of them I found it the last time in past Monday, and while I was talking to a dev team and trying to explain them why wasn't the query having the desired behavior. So some of them are very frequent, some others are not so frequent as that. Okay. Regarding the questions, if possible, I would ask for you to hold them until the end of the presentation, and I will leave some minutes at the end of the presentation trying to answer your questions. Jump to what really matters, which is the demos. Okay, and here we go. Let me place it here. Okay. So I hope you guys are seeing the screen, right?
Yes, we can see SSMS.
Okay, great. So first thing I wanted to tell you about is instant file initialization. well, what is instance file initialization? This is picked up from Microsoft documentation. Basically, when we deal with files at the file system, database files, I mean, we need to create a database, we need to restore a database. Imagine that's, for instance, you have to restore large databases from production environments to quality environments for testing purposes, whatever. Sometimes these can take a lot of time to do. But part of this time actually is used not by creating the file, but by zeroing the file. It's like, you know, filling up all the space with zeros first, and then the file gets created. And that can take lots of minutes, depending on the velocity of the disks and depending on the volume of the databases and their files. So there is one thing called instant file initialization that can help us out in this process by not by jumping the part of zeroing the files, okay? So first of all, how can we see if it is enabled at instance level? We can execute this query here, and we can see that it's enabled for my instance, okay? So right now, let me try to demonstrate this. My disks are really fast, so it's kind of difficult. It's kind of hard for me to show the huge performance gains that we can have, but I hope you guys can have just a little glimpse of it, and then you can try it yourselves. So I'm going to create a database with a file with 60 gigabytes, okay? And I'm going to do this with the instance file initialization enabled. And here we go. Let's see how long it will take to create this 60 gigabyte database. That's it. It was instantaneous, okay? And yes, it does have the 60 gigabytes. So it does have the size, but it was instantaneous. So what happens if we do this without instant file initialization? Well, I'm going to remove instant file initialization. How can we do this? Enable it and disable it. It actually happens outside a SQL Server sphere, okay? So I'm going to open the local security policy application here. I'm going to the local policies and to the user rights assignment. And there's a policy here that's called perform volume maintenance tasks. Now, if we take a look at it, we see that this account, that is the account of the SQL Server service, is placed in here now. I'm going to remove it. And once I do, and since that account is not a member of the administrators group, instant file initialization will be disabled. But bear in mind that for it to take place, we really need to restart our SQL Server instance, okay? So it still appears here as being enabled. So what I'm going to do now is that I'm going to restart SQL Server instance, just the service. Here we go, and restart. And once it comes up again, then instance file initialization will be disabled. And hopefully we will see time increase in creating this database, okay? So here you go. It's not enabled now. I'm going to drop the database and I'm going to recreate the database that was instantaneous a little while ago. And now, as you can see, it's taking more time. These disks are really fast. And if the disks are not so fast, or if the volume is a lot larger, this can mean many minutes in each operation. And if you need to restore large databases on a regular basis for demonstration purposes or for testing purposes, whatever, this can really save you a lot of time, okay? So I guess that, as you can see, it's taking, I hope it won't take the entire hour. I have still one or two things to show you. Okay, it's done. So this is it. So this is the first enhancement, if you like, and it's a really quick win. Also, make sure to read about the security issues that it could bring by not zeroing the files, I mean. So what am I bringing now? The second demonstration is going to be about this, indexes, but not indexes themselves. I mean, imagine that you have this perfect index. You have created it and it is a perfect index and it gets used. Only sometimes it does not get used and you go nuts about it. How can it not be used in this so great situation, okay? Well, first of all, let me show you what would happen here. I'm going to execute this and we have a Paradise Island, a little bit like the one I showed you earlier, you know? And we can see that we have this perfect index. We're making an index SIG. It's a really great index and it's there for us, okay? For this particular query, okay? Now we have an index SIG and then we have a row ID lookup. Basically, the rest of the info, the rest of the data is in the heap. So SQL Server needs to, once it finds this postal code, it needs to go to the heap to fetch the rest of the data that is being required. By the way, is there a way for us to know where every single row is physically stored in SQL Server? The answer is yes, we can know that. There is this virtual column here with this physical locator, okay, that gives us that information. Of course, by using it, we will not understand anything. So thankfully, there is this other view here that we can use to translate its value for us. I'm going to show it to you, okay? So this actually will show where does this specific row live in SQL Server. So this is the value that is produced by the physical row location. And this is the formatted view of it, okay? So it's in the file number 1 of the database and this data page and at slot 83. If we are really curious about it, is there any chance for us to see at low level the contents of the data pages? Once again, yes, we can do that. So we're going to use this undocumented, I guess it's one of the most documented comments. It's undocumented since it can stop existing at any moment. It's the BCC page. It allows us to look at the contents of a data page. We're going to put as parameters, we're going to put the database name. Then as we see the file number inside the database name, this is the file number. And then the file, the number of the page, of the data page that we want to look at. And this is just for us to bring the details, more detailed information. Let's see what it brings us. Okay, and now let's look for slot 83. So I'm going to scroll this down a little bit faster, 26, 40, 60, and here it is, okay. And here it is, 1, 2, 3, 4, and Paradise Island. Okay, so we can actually look at the contents of our data pages in depth. Okay, so this is a cool thing. It's more out of curiosity. Sometimes it's useful for us to be able to check it out in several situations. Okay, but now let's go back to our main situation here, had to do with using the index. So what I'm going to do here is that I'm going to flush all data pages to disk, okay? So that we don't have anything regarding this database in memory, no database in memory. We can check it out by using this dynamic management view that is very useful, okay? And now if we're going to look for how many cached data pages are from this database in memory, we can check out that we don't have any. Now let me just take this out of here. Okay, so we don't have any. And now I'm going to perform this select. And I'm not going to see the execution plan right now. One thing that I'm going to do is check out how many data pages were brought to memory. 74. It's very little. The value is very little. Okay. And so yes, it did use the index, which is great. Now I'm going to do this exact same query. Functionally, it's the exact same thing. It has just one tiny difference, but it will have a huge impact. Okay. So once again, let's flush the data pages into disk. I don't have data pages at this moment from this database in memory, and I am going to issue this query, which is identical to the other one. Okay. Remember that the first time it brought 74 data pages from disk to memory in terms of I/O. Let's see what's going to happen now. Okay, let's take a look at it then. And we have, whoa, it's not 74. We have 77, almost 78,000 data pages. So this is the entire table that was brought in, okay? And we were not expecting this eventually, okay? Well, I mean, aren't we looking for the exact same thing? Yes, we are. It's the exact same query with the same predicate, okay? So what is the difference here? Well, the difference here, and it's a very important thing, is that the data type for this column is actually a varchar, okay? And when we are using this literal here, this is a varchar, whereas this is not a varchar. This is version from varchar to hint and not the other way around. And it cannot use the index. So can you hear me or?
Yes, you dropped out for a few seconds, but I think it's good now.
Okay. Okay. So did you see the part in which this query brought a lot more data pages than the first one?
Yes, we did. Just a few seconds of your speech where your camera froze for a bit, but I think we got all the content and what you said.
Okay, good. So let's take a look at this and let's see what happens in here. We have a table scan and not an index seek, okay? And the reason why we're having this is because of this convert implicit that may affect the seek plan. Yes, it may affect it. It did affect the seek plan, okay? So this is a problem. And so what I really want to sign out here is that it's extremely important for us to, in every predicate that we are working on, always use the same data types as the columns that we are working with, always. In this case, this is only a literal, okay, so it's very easy. Where this type of situations happens the most is when we're speaking about stored procedure parameters or in functions in which many times we have a sort of copy paste from one to another. And then it's like, well, okay, it's not the same data type, but it's compatible. So who cares, right? Well, this is the kind of thing that can happen. Okay, imagine that you know that the database design was not so good, and you know that the column only has numeric values. But unfortunately, those numeric values were not defined inside the table in the column as an int, but as a char column. You will have this problem. Some of you might say, well, I have had these situations and the index was actually used. Well, that can happen as well. This doesn't happen all the time. It can happen or not. Why? Well, it depends on the precedence of the data type, meaning that there is a table of precedence in SQL Server. Okay, I'm going to show it to you. Okay, so as we can see, the int is here, whereas the varchar is here below, meaning that actually this one is the one that needs to be converted to this one and not the other way around. And that is why in this particular case, we saw this happening. Okay, so pay a lot of attention. Make sure that your parameters have the right and the appropriate data type. That is really, really important to ensure performance in your queries in case you intend to use indexes. Let me show other situations that are kind of common. In this case, we're doing a query that is using just part of our column. And so we're just interested in the first 2 characters of it. This is very common use, and it's not a good way to use it. Why not? Because once again, let's take a look at what we are going to have. If I execute this, once again, I'm going to have an index scan here, okay? Not an index seek, okay? So what should I do? Well, I should not perform the transformation in the column. I should perform the transformation on the other side of the predicate. When I can do that, I should always do that. So if I transform this query in this, in which the transformation actually happens in this side and this one is immaculated, it doesn't suffer any kind of transformation. Now the index can be used in the right way, and we are going to have an index seek. If we execute both of them and look at the execution plans, let's see what it tells us. So we have an 82% effort on the first one versus 18% effort on the other one. And for us, it's just a different technique to write a query. It's exactly the same thing for us, but these little tips are very important in our day-to-day, okay? So this is a demo regarding why sometimes we go nuts about not having our perfect indexes used, okay? Let's see what's the next demo about. I'm going to put this like this. It's going to be easier. Okay. Okay, what's this? Okay. So we have a little table here, which is really a little table. It has only 1,000 rows. And I'm going to try to delete 1 row from this table, okay? Nobody else is working here. It's just me. So SQL Server is all for me and all the resources are mine, okay? So this should be really fast. As I told you, I have a good machine. So it was actually very fast. Now, I have another table that is very similar to the first one, and that also has 1,000 rows only. And if I'm going to delete exactly 1 row too, it's not going to be immediate. Well, this is a demonstration. The real life situation took a couple of hours, and people were starting to get worried about it, okay? How can deleting 1 row in a small table take so long? There's no blocking issues, nothing like that, because nobody was working at the time. So how can this be? Well, let's check it out. The thing is that both tables have foreign keys. They are being referenced by 19 other tables, okay? And one of them does not have indexes. The second one does not have any index in the foreign keys, okay? So the foreign keys are there, and they need to ensure when I ask to delete 1 row from the mother table, they need to ensure that there are not related rows with that foreign key in order to allow or disallow the operation. And it takes a lot of time doing that. It took a lot of time doing that if there are no indexes in the related tables. Why? Because the related tables, all of them had lots and lots of records in it. So also bear this in mind, and it might be useful considering the possibility to create indexes. So they're saying it in another way. Foreign keys are often good candidates for indexes as well, okay? And this is one of the situations that can benefit from it. Not only on the joins, etc. This is also one of the situations that can benefit from it. Okay. Now, the other demonstration has to do with collations. And well, first of all, we're going to speak a little bit about what are collations, okay? And how they interfere and what is their role in our databases, okay? It's a very important thing. And we also are going to see whether or not they can have some kind of impact in performance, okay? So first of all, what are the levels we can define collations? We can define it at 3 levels: the instance level, okay, the database level, and then also at the level of the char columns in each of our tables, okay? When we create a database, if we do not specify the collation, it will inherit the collation of the instance. When we create a table inside our database, and if we do not specify the collation for the columns in the table, it will inherit the ones from the database, okay? We can override that if we like. And I'm going to create an example here for us to understand what do collations control in character data anyway, okay? So I'm going to insert one row of possibly the most known people in from Portugal at the moment. And I'm going to place Cristiano Ronaldo in both columns. What is the difference between the two columns, by the way? This column is a varchar and this column is an nvarchar. So this column is a non-Unicode and this one here is a Unicode. We'll get back to it a little bit in a little while. But for now, let me see if we can find anything inside these columns with this content, Cristiano Ronaldo. Yes, we can. Well, they are exactly, we are looking for exactly the same thing that we had put inside the table. So it would be very hard if we didn't have the results, okay? Now in this case, will there still be results being brought to us? Let's see. There are. Why was I even putting the question, would there still be results being brought to us? Well, the question is that in this case, we have uppercase in the C and in the R, and we have lowercase in the C and in the R. So it's not exactly the same thing. Now, in this other example, let's see if we can, if it brings any kind of results. And no, it does not bring any kind of results. Now, why not? Well, when I showed you a little bit ago, what were the levels at which we could see the collations, this is the name of a collation, okay? Its name gives us many things. One of them, it tells us, for instance, that the characters that will be, that we can use here are Latin characters. So it is prepared to understand Latin characters. The CI stands for case insensitive. And that is why it didn't care about the upper C or the lower C. It would always bring results regardless of being uppercase or lowercase. But AS stands for accent sensitive. And that is why in this last example, when I had this high here with an accent, it did not recognize it. And this is very meaningful because depending on the type of searches that we can make in our text fields in the columns on our tables, we should know the impact that choosing one or another collation will have, in order to avoid situations that will bring 0 rows when in fact there are rows in there. So it is very important for us to know what is the role of collations regarding character data. Okay, let me show you some examples of collations. We can see that some of them do not start by SQL, which is the case of these ones, and others start by SQL. So basically, the ones that start by SQL are designated by SQL Server collations, and the others are Windows collations. Okay, they are different. They have differences, and we're going to learn a little bit about those differences and what kind of impact they have. So, as I said, let's revisit the varchar versus the nvarchar. So the varchar is one type of data in which one character is represented in 1 byte only, meaning that it's not enough to represent all the characters that we have. So actually, the value that is saved in the column is depending on the collation that has been chosen. As I told you earlier, for instance, the ones that we saw, the one that we used in this database is for Latin characters, okay? So it will be prepared to understand and to save Latin characters. In the case of nvarchar, which is Unicode, each character will occupy actually 2 bytes inside the column. So it occupies twice as more space than the non-Unicode. But thanks to that, the entire representation of the character can be saved inside the table, meaning that its value will not be depending on the collation that is chosen. And this has relevant situations. So, well, truly, there are still some characters nowadays, like the emojis, for instance, that still have surrogate pairs, but let's leave that for another day. What I'm going to do here now is to create one table in which I'm using 2 columns that are non-Unicode and other 2 columns that are Unicode. If I don't specify the collation for the columns, it will inherit the ones defined at the database level. And that's what I'm going to do for 3 of them. And for one of them, I'm going to specify a different collation, which is a Greek collation, okay? Here we go. Now, I'm going to insert this inside my table, which is, this is Greek, by the way, okay? And I don't speak Greek, okay? So, but I can assure you that this should mean welcome, okay? At least that's what Google Translator said to me. So I believe that it will be true, okay? So let's insert this in our table. And let's put this a little bit, okay, so that we can see this a little bit more, okay. And let's see what is really saved in our table, okay, once we did this. And let's try to understand what happened here. So for the first column, what we tried to put inside it was lost. And why is that? Well, it's actually very simple. Because these characters are not Latin characters, and because this is a non-Unicode. So it can, at this point, it only understands Latin characters, not these ones. So this is not suitable for it, okay? This one here is also non-Unicode, but the difference is that I already said that I would like to save Greek characters in here. So it did receive them appropriately, and it saved them appropriately. And now we have this one. This is exactly what we expected, as the behavior that we would have expected, because it's a Unicode, it's Envashar, it's a Unicode, and so it will save it properly regardless of the collation, right? So this is exactly what we were expecting. But what about this one here? This one here is also a Unicode. It's exactly the same as the other one, and it did not save it correctly. Why does that happen? Well, I've seen this happen a few times. If you look carefully, you will see that we have these capital N's here. Now, what these capital N's mean, they stand for, is Unicode. That is because we are using a literal. And since we are using a literal, when we want to consider it as a Unicode string, we must use the capital N. Otherwise, it will be interpreted as a non-Unicode character. And that is why it was lost from here to the when it was inserted in the table, okay? So be careful when you work with literals, even if it is on Unicode characters, but if you are working with literals and trying to insert them in your tables, and if the character set is different from the one that is defined by the collation in the specified column, okay? So, like I said, and like I showed, we have different collations. We have collations that are for SQL Server and collations that are Windows collations. All the ones that start by SQL are SQL Server collations, and all the others are not. SQL Server collations are the oldest ones. They've always been around, and Windows collations came after. There was a time in which Microsoft said that SQL collations would disappear. And why was that? Well, because SQL Server collations, they follow different sorting and character handling rules in case a field is a Unicode or non-Unicode. Yes, the collation will define not only things that are related to how it saves the data, but also how it will process the data. In this case, SQL collations have different rules. So if you have a column that is non-Unicode, it will follow some different rules that differ from the ones that if you have Unicode. I'm going to show that to you, okay? So what I'm doing here is that I'm using a SQL Server collation in both cases, okay? Here, I am using a non-Unicode column, and here I'm using a Unicode column. And I'm inserting inside these tables exactly the same data. By the way, this is a location near the sea in Portugal, which is a pleasant one. And it will allow me to show what is the difference here between these two situations. So I'm going to select the data that I just put inside a table, ordered by the name, and we're going to see that it will produce different result sets. So as you can see, they are not ordered in the same way, okay? So the SQL Server collation has different rules applied to non-Unicode data and to Unicode data. Windows collations do not. They will have the same set of rules applied to both, and it will be the ones from Unicode data. Oh, let's take a look at it. I'm going to build the tables now, but with Windows collations. Here we go. And let's see now what happens here. As you can see, in this case, we have exactly the same result set. So same rules were applied, but this means that in case I have a non-Unicode, then there are some conversions that need to be performed in order to apply the same set of rules. And since these rules are a little bit more complex than the ones that are applied using SQL Server collations, this can have an impact in performance as well, okay? And maybe, I don't know, maybe that's one of the reasons why SQL Server collations still remain. I don't know, okay? So let's take a look at this. I'm going to perform a query over this table, and in a varchar, which is a non-Unicode column, okay? It's a small table. It's a small table, and especially the average of character length in this column should be around 20, 25 characters. So it's really small. There's no big impact in this case, but in the case in which we have larger tables or larger lengths inside the columns, it can have a huge impact, a very significant impact. So we're going to see what's coming from here. And okay, we had 4 seconds, okay? In 4 seconds, we have our result, okay? Now, what if I force in the query, I can force it to use a different collation. And this is a cool thing. I mean, although the collation inside the column is a Windows collation, there is the possibility for us, if we are dealing with this type of searches, we can force another collation to be used in the query. This will obviously need to compute scalar, but will it bring us any kind of benefit? That's what we are going to find out, okay? So we had 4 seconds on the first one, and let's see what happens here. Immediate, okay? So there was a performance impact, and I can execute this 10 times. You will see that performance impact every time, okay? And that is exactly because of what we saw before, okay? There are different rules, and the rules that are applied to non-Unicode values in Windows collations are more complex, and it tends to take more time, okay? So this is also one thing that you can consider if you need to search inside big strings, and if you have Windows collations in them, you can eventually consider the possibility to use this, okay? Now, I would also like to show some situations that are not quite related with performance, but they are related with problems that come from collations, and I wouldn't feel good if I would bring collations here and not speak about them. Sometimes we have collations clash situations, okay? Usually when we are dealing with temporary tables, and when we do specific operations with those temporary tables and between them and the tables in our databases in which the collations are different, okay? So just going back to the beginning here to show that in this particular case, I do have one collation in my server, in my SQL server, and another, a different one in my database. What will be the collation of tempdb, where all temporary objects are stored? It is always the same as the SQL Server instance. So in this case, tempdb will have this collation, whereas my database will have this collation, okay? Let's see what situations, what problems can arise from here. So I'm going to create a temporary table, okay? This temporary table with the table that is in my database, and I'm going, I believe I'm receiving a note that the internet isn't stable.
Yeah, we had a second or two drop out again, but I think it's good now.
Okay, sorry, I about that. There's not much I can do about it, unfortunately. Okay, so as I was saying, I'm going to show you what's going to happen here. It's basically an error. This is the collation clash. There is a conflict between one collation and the other. They are different, and they cannot, since they're different, they cannot apply the rules to compare these two columns or their data, because they have different rules to do so. And this is a common problem. In this case, I am joining tables using these char columns. It could also happen if, for example, I am concatenating strings. Any operation that needs to have some kind of operation between one column from one collation and another column from another collation will provide this kind of error. So yes, the best thing would be to have the database having the same collation as a SQL Server instance, and also inside all their columns in their tables. But we know that that's very hard to have, especially in a situation in which we have many databases inside one server and with many applications with many specificities. So we need to be aware of this, and we need to know how to address this issue if we have to deal with it. One way to do this is when I create my table, my temporary table, instead of not specifying the collation, I could use this instruction here. What I'm saying here is that I want it to be to use the same collation that is in the database in which I'm creating it. So the database in which I'm creating it is this one, and it will inherit this same collation here. And now if we try this again, there is no problem. We can do this, no problem at all. Okay, so we can also use this in the query, force it in the query. It's not so good because if you have many queries going on, you will have to do this in all of them. But if you are going to use this seldomly, it can be a solution. Okay, and obviously you can always specify the collation that you specific collation if you want to. So all of these are other ways to deal with this problem. Okay. So we handed this demonstration, and Catherine, I know it was my fault. I said that we would leave questions to the end, but I believe that perhaps this would be a good time for, if anyone has some kind of questions, to drop them. So because we already have seen a lot of things, so maybe it would be a good time for dropping some questions.
Yes, we don't have any questions in the Q&A panel, but a few people have written a few comments in the chat. So Jeff said that your demonstration on indexing foreign keys and how that can improve performance was very good. And a follow-up to that, I'm not sure if that was to Jeff or to you, but a question was, why wouldn't you index foreign keys? So I'm not sure if you want to maybe say a few things on that.
Well, okay. The indexes may be good for select operations, okay? But they will always be bad for insert operations, for instance, okay? So if you have a table in which you have many inserts and you don't have that many selects, you should choose, you should think about using them, then there's not really it's not good, you know, to create them. So creating index is not an answer for anything, for everything in performance, and in some cases it's even worse to have them than not to have them. So answering the question, I guess that we need to look at how we are going to use those tables, what we are going to do with those tables, what kind of queries we're going to do with those tables, and then we can choose whether or not to create indexes and why. Because just creating them just because, okay, let's do it, might not be good, okay? In this case, I wanted to delete one specific row from a table. Usually, what happens is that if you have foreign keys, you can have a situation in which you will have a delete cascade, but imagine that you don't. So the right way to do it would actually be to delete all the rows from the child tables before you would delete it from the main table. So it actually depends. It's not we should not always assume that, okay, we're going to do this and it's going to be better. We're going to create the index in here regardless of what we're going to do with the table, okay?
All right, thank you. And I think the only other comment was from Alexander, who said, why not use database default collation? But then you showed that just a few seconds later. So that was a great question, Alexander, considering that you answered that just after that. So I haven't seen any other questions come in, but for those of you on the call, if you have any more questions, just pop them in and we can take them at the end of the session.
Okay, so I'll carry on then, okay?
Yes, go ahead.
So demo 5 is how to drink a beer. No, I don't think it's that. No, it's not that. That's another demo. It's another demo in another deck.
We'll save that for after the session, I think.
Right. So this one is a fine story that actually happened to me a few years ago. And I saw it happening. It did not happen just once. It happened more than once. But the first time it happened, I took some time to realize what was going on. The next time it happens here or there, you already have an idea of what can be happening. And I would like to share it with you. Okay, I've seen this happening to some colleagues of mine as well. So it's not just one situation. And it has to do with this. So basically, I was trying to see the state in terms of disk sizes, etc., etc. I don't remember what was the purpose, but I know that I wanted to do it in the morning, and I would take a look at it at the end of the day as well, and then make some kind of report. It's not really relevant for now. But when I came in the morning, you know, there were some data inside the dbadmin databases, and I produce some sort of a query. And let me just assure you that we have the auto create states on and the auto update states on as well. Okay. And I'm going to free the proc cache, make sure that there's nothing in there at the moment. And I'm going to execute this. Okay. So I executed this query, sort of, and it was pretty fast. And we had this this plan, this query plan. I took the results. I don't know what I did with them. I did something with them, and the time went on. You know, so now it's not 9 a.m. anymore, and I'm going to try to simulate a situation in which records are going to be placed inside the tables that we're going to query in the afternoon. Okay, so we have some some inserts that were being made inside those tables regarding collecting the information that we needed. So now comes the afternoon. Let's imagine that we are already in the afternoon, and now it's 4 p.m., not 9 a.m. anymore. And I'm going to run the exact same query. I left the SSMS opened. I left the window opened inside of it. It was the exact same query. I didn't change absolutely anything, okay? And when I ran that query again, I could see that it was not bringing the values immediately. It took a long, long time to bring the results. So that puzzled me a little bit. Why is it that if I'm executing exactly the same query, okay, when it's taking so long to bring the results, okay? Well, that's what we're going to talk about right now, okay? So I guess by now you have the idea. I'm not going to let this go on or else we would be here until the end of the presentation. So I will stop the execution and let's see that first of all, I'm going to show you the execution plan. I saved them to show you, okay? So we had this morning plan here. In the morning execution plan, we can see that we have a nested loop join, and we can see that we don't have many rows. We have 36,000 rows, okay, for the executions. It's a low level, it's a low value. Now, if we pick up the afternoon plan, we can see that the row is a lot thicker, and we'd have kind of 94 million, around 94 million rows for executions, not 36,000. So it's a huge, huge difference. It is a huge difference. And well, now, by the way, why would that number, why is this number so big here? Okay, why is this number so big in here? Now almost 94,000. Well, let's see. We have a lot more records in our tables than the ones that were headed. So in the meantime, so between the morning and the afternoon, when I ran the query again, it had a few more records, some thousands more. But in fact, those tables were filled with lots of rows. So adding 1,000 few more didn't make any difference. So actually, although the auto-update statistics is activated, it wasn't kicked, and the statistics have not been updated at all, okay? So if we now see, if we take a look at the number of records that satisfy the predicate, we can see that we have 2,601 and 36,109 in one table, and in the other. And since this is a nested loop join, so if we multiply one value by the other, we will have exactly this number. So it would never choose this plan if the statistics would have been updated. The problem is that the statistics had not been updated at all, okay? Also, another thing that I would like to show is that the statistic in this case has many rows, the table has many rows, but the rows that were sampled were a lot less than the rows that the table has got. And this is a very common situation because especially in auto-created statistics, in order to build them more quickly, and if the tables have lots of records, then a small sample of the records will be taken, and it may not be a representative sample of the records, and that can result in a problem, okay? And that is exactly what happens in this situation. also show you that, as we can see, between the morning and the afternoon, there were this number of rows, and in the morning there was only this number of rows. So we had only 100 rows added in here. So statistics were not updated. Okay, it was a small number of rows that was added, and the statistics have not been updated. This one, although this one had a full scan, but in fact, things have changed, but the number of records that have been modified was not enough to kick in the update statistics, okay? So the thing is that the query optimizer will rely on the statistics that it has, okay, to make its decisions. And well, it was doing what it should do. And here I'm showing one thing that we should not do, but it's one thing that we can do. And what would it do? What would be the behavior if instead of using a nested loop join, I force a hash join? Let's see. Would it still take a huge time to execute? The answer is no. It executes very fast, and it brings very few rows, by the way. Okay. So this is not the way we should go to, unless this is another query that we have in our pocket, and we know that why we're doing it. And today we can have it like this, tomorrow we can change it again. If we're doing this on a dev team, then we should be very careful when using this kind of join hints, because we are forcing a type of join hint no matter what is the situation and the data distribution, and it's a very dangerous thing to do. So be careful with it. There are other possibilities that we should try first, okay? One of the situations that we can do is that we can update statistics if that's feasible, if it doesn't take too long. And for instance, with a full scan here, okay? It shows, okay. Now, we can see that the rows and the rows sampled they've all been used, and this can produce more accurate results. There's also always 200 steps maximum. So if the tables have a large volume, even like this, it's not guaranteed that we'll have a good behavior, but it's worth a try. Okay. So in this case, I'm not using the merge. I just refreshed the statistics, okay, and it was immediate as well. And it is not using, okay, and it's now using a hash join, in fact, okay. We could also create an index in this field. It will also change the behavior. So I just wanted to show you that sometimes things, although, and then in this case, we are talking about SQL Server 2019, and so the threshold is a lot lower to kick in the statistics update. Still, we can have this kind of behavior. So pay attention, and if you see some things like this, remember what you saw in this presentation. Okay, so I'm almost at the end of this, and I'm going to my final demonstration. We don't have that much time as well left, but we have some time. I'm going to be able to finish it. And this is a question that, although seems to be already an old question, it's not as old as that. I mean, yes, SQL Server 2012 is very old. We've had a lot of versions since then, but it's also true that many clients, on the one hand, still have SQL Server 2012, but more than that, even if they have upgraded, many of them will still have their databases that have been upgraded to more recent versions of SQL Server, like 2019, for instance, but they kept the compatibility level as it was. This happens a lot of times. I've seen this happening many times, and so this regards also those situations, not just whether it is in a SQL Server version. before 2014, but if the databases, even though they may be lying in a more recent version of SQL Server, if they still have this compatibility level, okay? So we're going to take a look at some things, some interesting things that we can find. So the thing is that the cardinality estimator has been rewritten in 2014, okay? And there are different rules, there are some different rules that may affect the behavior of the queries, okay? So obviously, we hope that those differences result in enhancements and more performant queries. But unfortunately, it does not happen always that way. And it's important for us to bear in mind that this can have consequences. I mean, if we had some things running with the cardinality estimator before 2014, and if we then change them, we should be careful and pay attention if there is any kind of degradation in performance, okay? So this is 2019. I'm going to do a query here, and I'm going to take a look at the execution plan for this query. I'm also going to put myself in the right database. It will help a lot. Here we go. So 0 rows. It brings 0 rows. And what does the execution plan tell us? It tells us that it believes that it would bring almost 4,000 rows. Wow. Well, this is I'm going to try to pick the value here so that we can then check it later. Okay, going to pick up this value here. Okay, and I will bring it. So where does this estimated number come from? It gives us 0 rows, but it estimates almost 4,000 rows. Okay. Now, this is a database that is placed in a SQL Server 2019 and with a compatibility level of 2019. Let's do something. Let's create a new database and in this server, but with the compatibility level of SQL Server 2012. And let's see if the behavior is the same. So here we go. Now we're going to bring the table to this new database. And we are going to run the query from here. And let's see what happens. Okay, no rows, no surprise here. Now, what is the estimated number of rows? Oh, 1, okay? So totally different from what we had in the other one. So in here, we have an estimate that is completely different from the estimate that we have here. So the behavior can be different. The execution plan in this case is the same, of course, but it could get a lot different because based on these assumptions, the query optimizer will make choices. And those choices can then become very different, especially if the queries are complex, okay? So this is something that we should bear in mind. Okay. So another thing is, unfortunately, I see it happening a lot of times, is that queries that are made against other databases, but they are launched from another database. So I have a source database, like a launching point, and then I start launching queries towards another target, another database. What would happen then? Let us see. So we have this. This database here has the compatibility level of 2019. And this one that I just created has the compatibility level of 2012. Let's see what is going to happen. So as we can see, although the table is on the database with the compatibility level 110, the rules that are applied are the ones from the source database. And this is very important because we must know the origin. Where was the statement launched from? I've had a bit of a headache a few years ago with a situation like this because queries were being launched from different databases to the same one. And in some cases, it was running really nicely. And in others, it was a complete disaster. It was the same query, okay? But it was launched from other sources, different sources. So bear this in mind as well. Okay. So let's recap what we saw here so far. The CE has changed since 2014, okay? We can, if we execute cross-database queries, the CE version that will be used is the one from the source database, not the one from the target database, okay? Also, give a few tips. If we are in the process of migrating databases from an old server to a new server, we should create a baseline for the most critical queries, okay? So that, sorry, a baseline for the most critical queries, so that we can see if then there is some kind of degradation if we change the compatibility level, okay? Query Store, which is a feature that came with SQL Server 2016, can help us hugely with this situation. So we can activate Query Store, maintaining the old compatibility level, create the baseline, issuing the most complex queries, and then we can change the compatibility level, update it, and then we execute those same queries and we can see if there was performance degradation or not. It's very useful, okay? And act accordingly. So back to the beginning and trying to understand where does that estimate come from in the number of rows. So here we go again. Number of rows, almost 4,000. Okay. So we have a few dynamic management views here and another system view that we can use. It's very useful regarding information about statistics, okay, that we are going to use in here. And we can see once again that we have many of them that in which rows sampled are a lot less than the number of rows of the table. These are all auto-created statistics, okay? And in this particular case, we would like to see what is happening on the fourth column. By the way, this here is the number of the column inside the table. And this is actually the table. So if you take a look at all these strange names, that's what they mean, okay? This is the position of the column inside the table, and this is the table. If we pick this up, let's try one thing here. If I pick this up here, and if I do here, let me see, this is in hexadecimal as hint. I obtain this number, and if I now see if it relates to something in my database, we will see that, ta-da, here it is. So it regards this table, okay? So it's a strange name, but it actually is meaningful, okay? So let's take a look at our statistics in here. And as we can see, the number we already saw, but the number of rows sampled are a lot less than the number of rows. Another thing that we can see that is very interesting is that we're looking for the value 1,000, and looking at the values that we have here, we can't find any number 1,000, far away from it. We have the maximum one is 43. So there is no 1,000, okay? So in this type of situations, what does the cardinality estimator do? It follows a rule. And what rule is that? Okay, I'm going to show you. It's this. It's the square root of the number of rows. So the number of rows in the table is this, right? We're going to pick the number of rows in the table. We're going to place it here. And we're going to pick up the square root, and we have this, and now we are going to compare this number with the one we have here. So 3871.71, 3871.71. So that is how it got to that value, okay? With the new cardinality estimator. Now, another example here is what happens if I, instead of using the number, the 1000, if I use the 13, in this case, and looking at the statistics, we can see that actually there is no, it doesn't appear in here. So we have the 12, 14, and we don't have anything in between. So basically there is, in this sample at least, there is no 13. So what will it bring to us? See, like this. Okay, so in this case, it will estimate 1, just as it does in SQL Server 2012. Okay. And yet another case. In here we have the 29, and if we look at the histogram, it appears in there, but it has this number. Okay. Let's take a quick look at the histogram. Look for the 29. Here it is, and look at the rows. How many rows it has in here. Okay. And so this is the number of rows that it's going to assume and to give us as an estimated value here. Okay, well, this is not an accurate number, of course. So what can we do? Imagine that you have statistics with full scan, once again. On the table. Okay. And now we're going to take a look at these ones. So if we look at the 29 now, we see that the number, since we have an entire sample, it does give always integer numbers, not decimal numbers, of course. And let's see if we can have some more accuracy in here. So looking at this, here we go. Let's take a look at it. And this is 2019 compatibility level. So there we go. And this one here, we have the estimated number of rows is now 1 instead of almost 4,000. It's accurate, okay? And this one here is also 1, even though it brings 0, it will never estimate 0 rows, never. And this one, you see, 3,073. So it's very accurate. Okay. So as a conclusion, after migrating, if that is the case, after migrating and before upgrading the compatibility level, and because it may have huge impacts as we are seeing, it's important to try to create the baseline if we can for the most critical queries at least. Okay. And if all is fine, then great. We're all very happy. The migration is a success, and we can all go home, and that's it. But if not, we need to address it. So if it's feasible, we can try to use full scan for some statistics. It's not always feasible, of course. So, but if it is, it can be tried. Another thing that can be done is this. While maintaining or while upgrading the compatibility level, force the legacy cardinality estimation. Okay, this is also another possibility. It's not such a sledgehammer as leaving the compatibility level in an old one. Okay, and this can be used either at the query level and also at the database level. Okay, and why is it preferable to use this if necessary? And still trying to upgrade the compatibility level. Because in this case, you will not lose features, whereas in the other case, you are going to lose features. Let me give you an example. There is a cool function that can be used. For instance, use demo 5. Let's see. Okay. So if we have this, it says that this is not, we can't use it. But if we do this in another database, which is this one, with a higher compatibility level, well, now we can use it. Okay, so this is the kind of functionalities that you may lose if you don't upgrade the compatibility level. If I alter the database, this one here, okay, and setting the compatibility level to 150, compatibly, so many eyes. Okay, okay, so you looked at, now I can use it already. So this is just one feature. You have so many that you will lose the opportunity to use. So you can upgrade this, and if you need absolutely, or for some time while you need time to figure out what to do with the queries that add a regression, you can do this at the database level, which is just keeping your legacy cardinality estimation during some time, but you can upgrade the compatibility level. So it might be an option for you also, okay? So guys, thank you so much. It's time for you to wake up, okay? And well, I hope you liked, and then if you have any questions, feel free to ask. I will try to answer them the best I can, okay?
I've been awake the whole time. Thank you so much for that. We don't have any questions, but I'll leave it up for at least a few minutes in case people are typing now. But thank you so much for that excellent session. I wrote it earlier that many of the things that you showed today are obvious once you're aware of them, but these are things that new developers and maybe even business users who are not coming from the DBA world, like they constantly run into these things. So my additional tip is, if anyone's watching this and thinking like, I know all of these things already, keep sharing them with your coworkers and especially new developers, because they're crucial to performance. JD is asking, where can we get the scripts used in the demos?
Well, some of them might be available on the blog, and the other ones I will try to put them as soon as I can.
All right. Other than that, I'm seeing a lot of thank yous and good sessions.
All too.
All right, we'll hang out just for a little longer in case there are any last minute questions. But for those of you who are on the call right now, just be aware that this was actually the last session of the day in this track 1 of GroupBy. There were supposed to be 2 more sessions, but they had to be canceled, unfortunately. So if you are still interested in more learning today, hop on over to track 2, where there are still 2 great sessions coming up. All right, so if you want to, let's see, thanks for the session, great presentation. So you're getting a lot of good feedback. No more questions though. So I think maybe we can end this for today.
Okay, so thanks a lot for this time I could be with you, and until the next day.
Thank you so much, Etienne. Have a great day.
You too.
All right, and I will go ahead and share my screen just to make sure. Here we go. That people who might be popping in now can see that. Hop on over to track 2, and next session coming up in about 10 minutes, I think, is on Delta Lake with Azure Databricks. So if that's interesting, hop on over and enjoy that session. I'll be muting myself and turning off my video now. So I hope you all have a great rest of your day.